Assalamualaikum and good evening. My name is Ahmad Faris. I'm from DTK2B. My matrix number is 10DTK21F1017, and this is my presentation for DEE20023 semiconductor device. End of chapter. The first question is, by using a suitable diagram, explain how an N-type semiconductor can be produced.
Explanation: to make the N-type semiconductor, pentavalent impurities like phosphorus or arsenic are added. 4 of the impurities electrons form bonds with the surrounding silicon atoms. This leaves 1 electron free. The resulting material has a large number of free electrons. Since electrons are negative charge carriers, the resultant material is called an N-type or negative type semiconductor. The pentavalent impurity that is added is called a dopant, and the process of addition is called doping.
Question 2. Discuss the difference between a full wave center tap rectifier and a full wave bridge rectifier. For center tap rectifier, as the name suggests, requires a center tap transformer or secondary winding. For bridge rectifier, no center tap transformer is required in a bridge rectifier. Center tap rectifier uses only 2 diodes in its circuit. Meanwhile, bridge rectifier uses 4 diodes in its circuit. Voltage drop across 2 diodes of the center tap rectifier is less than compared to bridge rectifier. For bridge rectifier, the voltage drop across the 4 diodes of the bridge rectifier is more than the voltage drop across the center tap rectifier. The peak inverse voltage PIV of the diode in the center tap full wave rectifier is twice the transformer secondary terminal voltage, while peak inverse voltage PIV of the diode is equal to the transformer secondary voltage. Thus, this type of rectifier can be used for high voltage application. Question 3. With the aid of diagrams and output waveform, discuss the differences between amplifier class A, B, and AB. In class A, biasing a single active device, generally a transistor, allows it to operate in its linear conduction region during the entire input cycle. Biasing refers to the limiting of an input signal to a certain voltage or current range. Linear conduction means that changes in the amplified output of the circuit are exactly proportional to changes in the input. The class B input waveform is split. The device conducts during half of an input cycle, the other during the other cycle. The two halves are reassembled at the amplifier's output. At times, class B amplifiers are called push-pull because the outputs of the active device have a 180 degrees phase relationship. Class B amplifiers resemble class Bs except their active devices are biased, so both conduct during an overlapping portion of each input cycle. This sacrifices a certain amount of potential gain for better linearity. In example, there's a smoother transition at the crossover point of the output signal. Class AB sacrifices some of that efficiency for low distortion.